Students, today we will learn about interrupts. Interrupt means, what is the general meaning of interrupts? Disturbance. So here 8051 can receive interrupt from the external devices which are connected from the INT0 and INT pin, or it can receive the interrupts from the internal architecture also. So whenever interrupt signal came to the 8051 microcontroller, it has to stop its current program execution, and it has to receive the interrupt signal, and it has to serve that interrupt. Whenever 8051 receives interrupt, then it has to execute one routine that is called interrupt service routine. So according to interrupt type and interrupt to service, it will open one function that is called interrupt service routine, and it executes the interrupt service routine. So this is called interrupt handler. So generally we have 8051 has 5 interrupts, 2 external interrupts, nothing but hardware interrupts, 3 internal interrupts, nothing but software interrupts. So internal interrupts are generated by 2 timers, timer 0 and timer 1, and it is third interrupt is generated by the serial communication, that is TI means transmit interrupt, or RI means receive interrupts. So these are the 3 internal interrupts, nothing but software interrupts, 2 timers interrupts, and 1 is serial communication interrupts. And next type is external interrupts. We have INT0 and INT1 2 pins at pin diagram. So using these 2 pins you can connect the 2 external devices. Those external devices can interrupt the 8051. So these are called external interrupts or hardware interrupts. Now we will see the special function registers for interrupts. We have 2 registers, IE and IP. So IE register nothing but interrupt enable special function register. Using this IE register we can enable or disable the interrupts. So just look at this 8 bits of IE register. So 0 to 7. First we will see the 7th position, EA. So that is nothing but EA means enable all. Enable all means we can use this bit to enable the 5 interrupts, or we can use same bit to disable the 5 interrupts. Here all interrupts nothing but 5 interrupts. So you can set or reset this bit to enable or disable the all the interrupts. If EA is equal to 1 means you enable the all interrupts. If EA is equal to 0, you disabled all interrupts. So 8051 cannot receive any internal or external interrupts. Next come to the 6th bit is not used. 5th bit is ET2. ET nothing but enable timer. So here ET2. So 8051 is not having any timer 2. It has only timer 0 and timer 1 only. So ET2 nothing but timer 2. So this is also used in future. So timer 2 is not there with the 8051. And next bit is ES. ES means enable serial. So you can use this bit to enable or disable to serial communication interrupt. Nothing but TI or RI. So enable S means serial. ES means enable serial communication interrupt. So if it is 1, you are enabling the interrupt. If it is 0, you are disabling the interrupt. If you kept ES is equal to 1 means 8051 microcontroller can receive the serial communication interrupt. Next ET1. Enable timer 1 interrupt. So if it is ET1 is equal to 1 means 8051 can receive the interrupt from the timer 1. If it is 0, it cannot receive the interrupt from the timer 1. So enabling or disabling the timer 1 interrupt with the help of ET1 bit. Next EX1. X means external interrupt. So enable external interrupt 1. So this is related to the INT1 pin. So whatever device is connected with the INT1 pin, so that device can generate the interrupt. You 8051 want to receive that interrupt means the EX1 should be 1. If EX1 is 0 means 8051 cannot receive the interrupt from the INT1 pin. So EX1 means external interrupt 1. Next ET0. T means timer. 0 means timer 0. So enable or disabling the timer 0 interrupt with the help of ET0. So if ET0 is equal to 1, you are enabling the timer 0 interrupt. If it is 0 is equal to 0 means you are disabling the timer 0 interrupt. Next, EX0. EX means enable external interrupt. So this EX0 is related to the INT0 pin. So EX0 is equal to 0 means you disable the interrupt. What is that interrupt? External interrupt which is connected to the INT0 pin. If EX0 is equal to 1 means you are unable the interrupt. Next special function register is IP, nothing but interrupt priority. So using this IP register, you can assign the priority of the 5 interrupts. So here you know very well we have 5 interrupts, 2 external interrupts, 3 internal interrupts. External interrupts nothing but INT0, INT1 pins will generate the interrupts EX0, EX1. Internal interrupts nothing but 2 timers interrupts and 1 serial communication interrupt. So you can assign the priority among these 5 interrupts. So this is the 8-bit register, IP register. Now look at this, 7th and 6th positions are not used. 5th position PT2 nothing but timer 2 priority number. So here 8051 is not having any timer 2. So this is also used in the future. Next, PS means priority of the serial communication interrupts. So if it is 1, PS equal to 1 means you are assigning the higher priority to the serial communication interrupt. If it is 0, you are assigning the lower priority. Next, PT1 means T means timer. So timer 1 interrupt priority. PT1 priority of the timer 1 interrupt. So if it is 1, higher priority. If it is 0, lower priority. Then PX1, X means external interrupt. So what is the priority of the external interrupt? 1. If it is 1, higher priority interrupt. Higher priority you are assigning to this interrupt. If it is 0, you are assigning the lower priority to this interrupt. Then PT0, nothing but timer 0 interrupt. So PT0 is equal to 1 means you are assigning the higher priority to the timer 0. If it is 0, lower priority. Next, PX0, external interrupt 0, INT0. Nothing but if PX0 is equal to 1 means you are assigning the higher priority. If it is 0, you are assigning the lower priority. So using IP register, you can assign the priority of the particular interrupt. Example, I have written 2 interrupts priority is 1 means the two interrupts are having highest priority. So now we will see how to assign the priorities to the interrupts. So let us take one example. PS is equal to 1 means I have assigned highest priority to serial communication. PT1 is equal to 1 means even though I have assigned highest priority to timer 1. So these are the 2 interrupts got highest priority. Whenever 8051 receives these 2 interrupts at the same time, then which interrupt will get the service first? So here 2 interrupts having highest priority and at the same time 2 interrupts received by the 8051. Then how the 8051 will serve these 2 interrupts? Because this is the tie. So here we have one table which is used to solve this type of problem. So example, whenever I have given highest priority to the serial communication interrupt as well as timer 1 interrupt. So according to this table, timer 1 will get the service first. Next, serial communication will get the service next. And next one is interrupt destination. Here interrupt destination nothing but absolute addresses of the interrupts. Whenever a interrupt came to the 8051, it may be internal or external. So it has to execute the interrupt service routine. So what is the address of interrupt service routine? Nothing but this table is giving that interrupt service routine absolute address means physical address. So look at this table. External interrupt 0 absolute address is 303 0003. Then external interrupt 1 0013. Timer 0 ISR address is 00B and timer 1 ISR address is 001B. Serial communication ISR address is 0023. So this is the interrupt destination or interrupt absolute addresses. So these addresses nothing but interrupt service routine addresses.